So as promised last time, we'll be having a look at an example question on circular paths. And this question is from summer 19. This is paper 42. And the question number is question 8. So this is the question. An electron is traveling in a vacuum at a speed of 3.4 into 10 to the 7 meters per second. The electron enters a region of a uniform magnetic field of flux density this much, as illustrated in 8.1. So the field lines are also given, and this is entering at an angle to the field lines. So the question says the initial direction of the electron is at an angle of 30 degrees to the direction of the magnetic field. When the electron enters the magnetic field, the component of its velocity Vn normal to the direction of the magnetic field causes the electron to begin to follow a circular path. We know this. So first we need to calculate Vn. So the one which is going to be perpendicular to the field is this one. That one is not with the angle, so it's going to be 3.4 into 10 to the 7. And since it's not with the angle, it's going to be sine 30. So this answer will turn out to be 1.7 into 10 to the 7 meters per second. Right? Then it says the radius of this circular path. So again, for the radius, you have to derive this again. And even if you don't want to, if you remember this, you can also do that. But just for the sake of revision, I'm going to do this again. So the centripetal force mv square over r is provided by the magnetic force on a moving charge bqv. V's cancel out like this, so r becomes mv over bq. So this is a electron, right? So from the formula sheet, its mass is 9.11 into 10 to the negative 31. The velocity which we just found out, again keep it to more significant figures, but because sine 30 is exactly half, this value is also exact. Divided by BQ, so B and Q. So B was 3.2 millitesla and Q is again the fundamental charge. So 3.2 milli means 10 to the negative 3, and the fundamental charge 1.60 into 10 to the negative 19. Calculating this turns out to be 0.030 meter, again to 2SF. State the magnitude of the force, if any, on the electron in the magnetic field due to the component of its velocity along the direction of the field. So does the velocity in the direction of the field cause any magnetic force? The answer is no. So it's zero force, right? It's no force at all. So we talked about this in one of the lectures, if you remember. We said there are two ways in which a charge could not experience a force in the magnetic field. One is if it's not moving, or the other one is if it's moving, but it's moving along the direction of the field, so parallel to the field. So this next part of the question says, use information from A and B to describe the resultant path of the electron in the magnetic field. So the one which is in the same direction as the field is not exerting any force, but we know it's going to take it forward, whereas the vertical component is going to cause it to create circles. But it's going to be forward, so we can say it's going to be a helical, or you can say a coil-like path.